Now, I'm part of the tribe. We live out here. Cindy and I, Cindy will be, you all know Cindy, right? If you haven't met her, you should. We moved out here about 15 months ago. We're having a great time, but gosh, I go back to college. It's like, with the partying and everything else today, like, I'm not going to drink today. I said, oh, well, you mean during daylight or later? Anyway, great to be here. We've really enjoyed living out here and getting to meet many of you and know you. We hope folks we haven't had a chance to really sit down and converse with that we get a chance to. And I appreciate you coming out here this morning. As many of you know, if you've watched me over the years, I've visited schools a lot. And I just got a wonderful letter here from their grandchild that is now in meteorology, in part because something that I fostered in her many years ago. Boy, that means a lot to me. I love to go out and visit the schools, even now after all these years, because I just like to talk about weather and I enjoy working with kids and stuff. But there is another reason I go out to the schools, and that is that frankly it's good business. I mean, you hope that after you spend the hour with the kids, they go home and say, Mom, we got to watch Mike Nelson from now on. Now, normally I don't have to motivate myself with that kind of greed, to go out and do it. I do it for the higher level reasons. But whenever I go out to the schools, I have my big box of weather stuff. And it's just an easy way to carry it. I have all the different things I want to show the kids in this box. Well, I used to go out and I just had the box, just a utilitarian box like this, nothing on it. And I did change that a few years ago because one day I opened up the schedule and saw I was supposed to speak at Eaton Elementary School, which is in the town of Eaton, Colorado, which is way north of Greeley. And we live down here, and I thought, that's going to be an hour and a half up there and an hour and a half back. That's going to use up a whole day. And I thought, hey, it's good for the kids and it's good business. So I got in the car, drive up Highway 85 through all the speed traps and stoplights and everything else. Finally get to Eaton, finally do my presentation. I get done and my voice is a little raspy after talking over 300 kids. And I feel a little tired, but I thought, this is really good because I've reached these children and they have a new understanding. And so I said, hey kids, are there any questions? And this cute little girl in the front row, little pigtails, raised her hand. She goes, who are you? So at that point I realized, if nothing else, the children would learn the name of the guy that came up there. All right, so these are all if you want to contact me, these are the best ways. My email, probably the simplest, is mike.nelson@hbgc.com. But you can follow me on Facebook and Twitter, and I'm even on Instagram now. My daughter said, Dad, you got to be on Instagram. So that's where I am. So if you want to jot any of those down, you can contact me with any thoughts, comments, questions about what we talked about today. Let's get rolling. Cindy Nelson, go to the first slide. This is actually my 40th year in TV. Yes, 1976 in my college professor's office. That's my first practice weathercast right there. And so this year I'm really excited because I'm going to be inducted into the Silver Circle of the National Television Arts and Sciences Group, which is a big award for the survivors that can manage to stay in this business as long as I have. Okay, Cindy, go on. Thank you. And it's our 40th anniversary of dating for Cindy and I, yes. There we are, we had our first date, 1976. Actually, on the first day I got my job in TV. And I had contacted Cindy, we've been kind of toying with going out. I said, I've got a job interview at the TV station. I get the job, let's go out and celebrate. So November 4th, 1976 was our first day. By the way, you are mic'd up, Cindy, so you can throw a comment if you'd like. We had the same hair back then. Look at that. Beautiful. All right. Now on to the next one. But I looked at one old picture of us and I thought, I've seen this picture before. And I realized that it was in the movie American Hustle. I mean, we really kind of had the same look going on. All right, Sid, go ahead with the next one. All right, I've been a weather nut since I was a little kid. We had a big thunderstorm that rolled through my hometown of Madison, Wisconsin when I was 7 years old. Trees down, street flooding, tornado warnings, large hail. It was great. And at that point I was so inspired I went into studying weather, and I actually built a little weather station in my backyard, which I still have the little box in our basement over here in HEB. And years later when I was working for WKOW in Madison, get it, WCOW, in the dairy state. We shot a promo about how long I've been doing weather. So City, go ahead to the next one. And when I was a kid, I had these big cardboard shirt box things because my father had a clothing store, and I would make these tables where I could keep track of the temperature, the barometer, and everything that's going on every day, and kept those for years and years. And I still, even now, being kind of the old school weather guy, love to get the paper maps and analyze the charts and stuff. A lot of the newer weathercasters now just look at it all on a computer screen, and they kind of laugh at me because I still have all the paper maps and do all the old school kind of stuff. But I think it's actually helpful because you sometimes really see some subtleties in the weather as opposed to just taking what comes from a computer. Now, I was hired at a company called Weather Central in the mid-1970s, and that's me on the left, and then that's my boss and my friend and my mentor, a gentleman named Terry Kelly, on the right. This was a weather consulting firm. We did forecasts for TV and radio for 40 stations around the nation. We did power utilities and ski resorts and agribusiness, and we actually provided the forecast for building the ice road for the Trans-Alaska Pipeline, because they had to have very precise forecasts on these blizzards that would come up and drop the visibility to zero, because they had these huge machines up there building everything, and they could run right over a pickup truck and not even know it if they couldn't see it. So that's the kind of stuff we did for highway departments and construction companies, and we developed the first television weather computer system. And that's my first real show on the air. It was July 4th, 1979. My college roommate snapped a picture. It was in color, we just didn't have a color TV at the time. So, summer of '79, these are some of the shots of what we were doing about that time. I borrowed a suit from the comedian Steve Martin, and most of what we did back then was all done the old-fashioned way. You had grease pencils and magnets and stuff. We did actually have a colorized radar display, which at the time was very revolutionary. It's the first time anybody had any color, kind of an electronic color picture on the air. And this is my salad days, the big hair. I'm glad I still have hair now. And look at this. You remember the guy Bert Convy? He was on like Love American Style. He did some game shows. Yeah, I mean, it's a doppelganger thing going on there. I actually was on his show once called Win, Lose, or Draw. You might remember that show in the late 80s, early 90s. And he said, you know, we kind of look the same. And I said, well, you know, if my TV thing doesn't work out, maybe I'll come and do your job. He didn't like that line girl. Back in the day, now Cindy and I got married in 1981, and back in the day, they don't do this much anymore, television stations used to do these tours where you could go on a trip to Europe with the television anchor, and people would buy into the tour. So we did one called the Hui Ohana, which is Happy Family, Hawaii tour with Mike and Cindy. Everybody thought Cindy was pregnant because we were Happy Family. That was the commercial we talked about. And so it was 15 days in Hawaii, 4 different islands, for a cost of $975. So we went out and did this trip. I think there's another Hawaii slide. Let's see, Cindy. Yeah, go to the next one, Cindy.
You gonna do another one?
Well, they don't do much anymore. Maybe we could. But the great part about it was, look at us. We're like newlyweds. We're in our early 20s, and most of the people that signed up for the trip were people that are our age now. Okay? And so we went where these kids on this trip, and all the people that were on the trip, there's about 50 of them, all they wanted to do for the whole 15 days, let's buy the newlyweds a drink. And Cindy and I spent 2 weeks absolutely hammered in Hawaii. Go ahead, Jim. All right, so early TV weather maps. Now, when I started my career, this is the way we made weather maps. They were actually lightweight little cardboard pieces, and you'd go to the graphics department of the TV station, which was a drafting table with pens in different colors, and you'd have the artist either draw one for you, like this fancy one with the Chinook winds, or you draw them yourself. No, we literally would hang these pictures that were about this big on the wall with some masking tape. The camera would shoot that, and you'd have a whole row of these lined up in the studio on the wall. The cameraman would just pan from map to map to map on your verbal cue. and he'd pan the camera. But sometimes Bob wasn't really paying attention, and so he didn't stay. And so it'd stay on the forecast map. So I'm really thinking, although eastern Colorado, near Sterling, might be only the 30s, in Denver, we're going to be in the 60s because of that Chinook wind. And then hopefully Bob would, and he still didn't get it. Finally be like, so we're going to talk about the Chinook wind, Bob. And Bob would panic then, and he'd pan across like 3 maps because he thought he was so far behind. Another problem that we had with this is that sometimes the little pieces of masking tape that were holding the map up would give way, and the map would suddenly go like that, and then just fall onto the floor. Which the people at home didn't really know what you were predicting, but they thought it might be bad. And there was one last thing happened. These maps were only about this big, but they would blow them up in the chroma key and the green screen, so they'd be about 50 times bigger. Well, one time we actually had a fly that was in the studio that landed on Kansas and started walking back and forth across the country. Well, the fly was like the size of a hamster, you know, it was huge. This big, ugly thing. Again, they didn't know what we were, it was like, you know, Mothra or something was coming out. So we knew in the 70s, maybe there might be a better way to do weather graphics. Go ahead, Sue. So this is the way that I would draw. Yeah, she's much better than Bob. This literally was how we make the maps back then. You would be drawing this piece of artwork. And so about the late 1970s, at the University of Wisconsin, there was a lot of research being done on using a televised satellite image that you could actually overlay wind fields or temperature contours. This would all be for scientific purposes. But this was starting to be developed. But it took a mainframe computer, you know, we're talking a vast amount of money to do it. Well, about that time, you might recall that the home computers were just starting to come out. This is the actual Apple II. Some of you may have had one of these. And so my mentor and dear friend Terry Kelly was working with some of the researchers at the University of Wisconsin, and they started to realize we could maybe make a simplified version of this computer system at the university and actually develop it for television. So this would have been late 1979, and this was on an Apple II home computer system that was so archaic, I call it Space Invaders or Pong by, you know, comparing it to today's video games. We could display 8 different colors on a black background, so you could have blue or red or whatever, but that was, and this became the first television weather computer system. Now, at the time, this was revolutionary. It seems very quaint today. And since Madison was kind of in between Milwaukee and Chicago and Minneapolis, bigger TV markets, these bigger markets took notice, wow, they got this newfangled weather computer system down in Madison. We ought to get one of those. And so we began to sell them around the country. And so my job in the late 70s through about 1984 was to travel around the country and install television weather computers and train the meteorologists how to use them. And this is kind of the early stuff. The very first system was called Color Graphics, and it was on an Apple II home computer that could show you 8 colors. Now, by the time we got to 1981, we had a computer called the Liveline 1, and it was a system that featured, and get this thing was the size of a microwave oven. We'd go in and say, this box can hold 10 megabytes of information. And people are like, oh my God, look, we're in the space age here. You know, you think about that now. By 1983, the Liveline 3, we'd sold over 300 systems, so we could display 16 different colors on a map. By 1985, we were up to where you had 256 colors displayed, and then your maps start to look pretty good. And then by just a decade later, we were up to 24 bits per pixel, which essentially is a full color system like we're used to seeing now. So you can imagine the 80s were a crazy time in terms of these new computer systems. And we weren't alone. There were some competing systems out there. And TV stations were flush with money still in the 80s. And they'd be spending money left and right. Well, these are some of the people that we helped train, because this was a privately held company, and our boss, Terry Kelly, would say, Mike, you're going to Denver, take Cindy along, because, you know, he knew we loved Colorado. And so Cindy and I actually helped train a lot of these people. And I don't know where some of you are from, but you might recognize some of these as your weather forecasters back in the day. And we'll flip back and forth on this a little bit. Of course, Stormy Rotman, the legendary guy here, and one of my TV heroes. Harry Volkman from Chicago, who just passed away, but he was one of the true legends of the business. This is George Winterling down here from Jacksonville, Florida. He actually did animated weather maps before anybody else, because what he did is he had a film camera that he had set up so it shoots straight down, and he had a map of the United States, and like claymation, he would move the weather front a fraction of an inch, snap a picture on a film camera, move it again, snap another picture, and he actually had these animated films of the weather. So that was pretty revolutionary. And then this guy in the middle, you might recognize, although he's a little heavier there, that's Al Roker. I actually brought the first weather computer to Al and trained him in Cleveland at the station he was working at before he went on to the network. And at the time, the computer systems were so new that it would be really exciting at a TV station that brought a computer. I mean, everybody, the salespeople, the management, everybody come down and see this computer. And at Cleveland, they decided to have a naming contest for the computer on the air, and people would send in what we should call the weather computer. And they had like Seymour Weather would be, you know, or something. Well, it finally ended up that Fred won, and that was an acronym for Forecast Radar Electronic Display. And so every one of Al's maps would have FRED on it. And he'd say, let's see what Fred's doing today. And one day, Fred blew a circuit board and was off the air for a couple of days till we could get a new one shipped into Cleveland. And the children sent Goodwill cards to Fred. Okay. Now, Stormy, when we brought the computer here in Denver at then KBTV Channel 9 in 1982, it was the highest rated TV station in the nation, had a 50 share at 10 o'clock. Today, with all the fragmentation of the market, we're lucky in Denver, any of the stations have more than about a 10 share. So you can imagine how many people were watching Stormy Rotten. So when we were assigned to do that one, my boss said, this is the highest rated station in the country, and you're training Stormy Rotten. If Stormy likes this, we can sell this to anybody. Because at the time, people would say, well, who's bought it? And if you say highest rated station in the country and Stormy Rotten, they'd say, well, it's good enough for them. And so he sent us out with computers and said, don't screw it up. So we get out here with all of these boxes of computers, and I'll never forget how Stormy walked in the first day. He came in with this scowl on his face, and he came up to me and he goes, and Stormy wasn't very tall, but he was an ex-military guy, so he had a personality, a presence. He came up and he goes, young man, I didn't want this blank blank thing. The management forced me to be here. I'm thinking, oh boy, this is a bad start. And you know, he didn't like this gimmick. He thought this was a gimmick. And so, first morning of training doesn't go well. We go to lunch, and it's Cindy and Stormy and some of the engineers and stuff, and he's just grumpy. And Cindy, why don't you take it from here? Just.
So Stormy and I were sitting talking, and I was a teacher. So I said, Stormy, I know this is really hard, but you have to stay relevant, and even I can do this. He goes, you can do this? You know, it's the 80s, and women couldn't do anything. And I said, yeah, I mean, I could show you what I know, and then if you still don't want to do it, we can go talk to management. So he and I went back to the station alone, and Mike was really mad at me because he did not know what we were doing. And I said, just trust me. And so we went back, and I showed him how to do a circle and made sure to close the circle so the color doesn't bleed all over your map. And he was like, this is so cool, so I could show a warning. And it could be like where I put it. And I said, exactly. And by the time they got back, he was ready to learn, because Mike was just plowing through everything really fast. And Stormy was that very methodical, thinking, very military man who needed it to see exactly, you know, what needed to be done. And Mike's, you know, doing every bell and whistle, and he wanted to know the basics. Start at the bottom and work your way up. So that's how Stormy came to trust Mike again.
By the time, you go ahead on to the next one. By the time I got back to station, Stormy's got a big smile on his face. He's making circles and arrows, and so I went back to Madison with Cindy. Stormy loved the computer. We sold thousands of them. The computer business continued, and now graphics look like this, all because of her. Otherwise, we'd still be using chalk. So Cindy, yeah, that's right. All right, so this is where we are today. Now, Cindy and I had always dreamed of coming to Colorado. Now, look at this. This is a 1979 Steamboat. Look at that red hair. Oh my. we decided it was springtime, so like the last week of ski boat being open, so we'd go out skiing, but we wanted to go back to Wisconsin with a tan, so we didn't wear any sunscreen. Oh, I looked like I had witnessed a nuclear test. All right, so go on. So we made a 6-year stop from Madison, St. Louis, worked at the CBS station there. That's not my high school yearbook picture. And then we've been here since 1991, and this is where we will stay. We're not going anywhere else in TV. Here's modern weather today. That was just last summer in the studio with the green screen. And of course, the tornado dance, which I will do later today. I've spoken to schools now for about 40 years, and Cindy and I have tried to do the math. I've probably spoken to 750,000 kids over the years. So now on to Colorado weather and why we're here today. Incredible. We love living in the state because there's always something going on. Beautiful in the fall, majestic thunderstorms. We get great hot, dry days too, and tremendous skiing and outdoor activities. But in Colorado, the weather can be life-threatening every single month of the year. And so with that, this was just last week. Okay? Same time, 3 o'clock in the afternoon, I have a tornado on the ground in Eads, Colorado. And go back, Cindy.
I'm trying.
And a viewer sends me this beautiful shot from Steamboat. Same exact time. Blizzard warnings and tornado warnings on the same day. So last week's storm was a pretty good storm, and this is what it ended up being. Look at the difference here. 4 feet of snow over parts of Boulder, Gilpin, Clear Creek County, all the way down into Douglas County. We, of course, had our couple of feet right here, but you go up toward Fort Morgan and up toward Sterling, they had a trace of snow. And that's all just in a fraction of our viewing area. We cover virtually the whole state. Now, this is actually, if you have not downloaded this, and I apologize for people who have Android devices. We don't have that software yet, but if you have an iPhone, search Snowcast, and this thing really works well. What did it print for us last week? It said like 20 inches for the storm, right?
Yeah, it was cool. It was so right on.
It really works well. It geolocates you and will tell you how much snow you're going to see in the next 5 hours to the next 48 hours. I recommend it. It's really pretty good. Okay, go on to the next one here.
Call me Bob.
Bob? All right. So a lot of times people are like, where am I? And that's a decent question because we talk about all these different things. So take a look. We are right on the edge of the Palmer Divide here. We're at 6,000 feet. Of course, it rises up a little bit higher. To the north, we have the Cheyenne Ridge. To the south, we have Raton Pass, the Raton Ridge. Southeast Plains, Northeast Plains. When we talk about Front Range and the foothills, that's the area in the purple. Northern, central, southwest mountains. Sometimes it says southwest. I'll say the San Juans and the La Garritas. You've got your Sangre de Cristo and your wet mountains right there, the San Luis Valley and the western slope. Now, all of these elevations play a critical role in what happens to the weather because when air goes uphill, it tends to cool, condense, you get clouds, you get moisture. When it goes downhill, it tends to dry out and warm up. So you can see why we have differences in the moisture. So if we had a northeast wind last week with this storm, anything that's up in Weld County, Morgan County, up to Logan County, that air is coming downhill. It's warming slightly. That's why they don't get as much snow up there. But as that air comes in toward Denver, it's pushing up against the Front Range and against the Palmer Divide, and it's rising as it comes over our neighborhood. So we get the moisture condensing out, and we get more moisture here. Then, on the other side of the Palmer Divide, into Colorado Springs, that air is sinking again. So we can have heavy snow here and all the way up to Monument Hill, and it literally can be partly cloudy in Colorado Springs. The Christmas Eve blizzard that you might have remembered in 1982, we had all that snow. Colorado Springs had like an inch because they were on the other side of the divide. Same thing happens when you get down to the Raton Pass area. That northeasterly wind would be rising again, so you get the heavy snow there. Conversely, if we have a southeasterly wind, that moisture will hammer Colorado Springs, but that air is coming downhill into Denver, and we don't see as much moisture. Now that's wintertime. In the summer, when we get a southeast wind, it's coming over the Palmer Divide and dropping down into Denver. The terrain tends to cause that air to make a little bit of a turn back toward the mountains. So it comes over and then it kind of slides in like this into the Denver area. That's called the Denver cyclone. And what that causes is a convergence line to develop from right about Castle Rock through Aurora, through HEB, and up through DIA. In other words, the air is coming down and curving back toward the west just a little bit, while we might have a westerly breeze coming down off the mountains, and we get this line where the air comes together. When the air comes together, it can't go into the ground, it's forced to rise, and we get thunderstorms that develop on this Denver convergence zone. So if you ever hear that, if you're following the Weather Service, they talk about the Denver convergence zone. We live right on it here at HEB. All right, Bob?
Will you put a star next time? Because I still don't know where we are.
Oh, we're south of the S in Foothills, okay? And we're right in the orange there.
Did you all need that? I needed that.
All right, so now we get different kinds of storms that come in here. And the three main systems that move across the country, the Pacific front, that'd be one where they've shown a lot of moisture coming into California. That usually will dump a lot of snow in our mountains, but not necessarily on the plains, because a lot of times the mountains scoop up all the moisture. By the time that front crosses down into Denver, it's lost a lot of its moisture, and unless it hangs around long enough to get some moisture from the Gulf of Mexico like it did last week, a lot of times on the Pacific front, mountains get hammered, and we're partly cloudy and windy here in Denver. Alberta clippers come down from Alberta province, and they race to the east. They tend to bring us strong winds in the wintertime, but not very much snow. Steamboat might get a good dump of snow out of them. But the Colorado hooker, that is that storm that forms that big red L that sits over the southeast corner of the state. And what that does is that draws the air around the low and gives us that northeasterly wind that we had just last week. And that's where you get our heavy snows. Now those typically then cruise on out and cause heavy snow in the Midwest as well. Location, location, location. It's not just for real estate. Here's just an example of how things can be strange in Colorado weather. In the wintertime, we can get the really cold air that's up around Fraser and Gunnison. You see 40 below in Gunnison. Well, that cold air pools in the mountain valleys. It's heavy, it's dense, it can't get over the hill. Go ahead, Bob. But meanwhile, we'll have strong winds aloft. They're coming down, sloping into Denver. One more, Bob. And we end up having those high, thin clouds, the Chinook winds, and it might be in the 60s in Denver, while it's way below zero up in Gunnison. Crazy weather, all due to location. All right, now, into springtime and summer, land spout tornadoes. We get a lot of these around here, and they are weak, short-lived, non-supercell tornadoes. A supercell is this big rotating storm. Brings you the big ones like in the movie Twister. So this is how we can get these land spouts, or sometimes we call them gustnadoes. This was on April 12th. We had a band of showers down in the south of us, and another band up to the north. Now, when these showers develop, they get the updraft that forms the storm, and then as they begin to rain out, that rain-cooled air comes down. It's a downdraft. That air flows out from the bottom of the storm in all different directions. Go ahead, Bob. And what you'll get are colliding boundaries. The air's coming out from the northern storms down toward Denver, from the southern storms up toward Denver, and guess where we are? Boom, right on that colliding boundary. And as that air comes together, forced to rise, you get a whole new crop of thunderstorms, and sometimes as that air is colliding and drawn up into a new thunderstorm, you'll get a little low-level rotation at the surface, and it's just like a figure skater. It tightens up, and you get these gustnadoes or land spouts. Now the reason they look a little different is a lot of times they seem bigger on the bottom than they are up on the top. So they almost look like an upside down tornado. They're usually not really strong, but they'll certainly move your lawn furniture around. So remember this one? Yeah, there we go. June 7th, 2009, the tornado over Southlands. And we can, although 90% of Colorado tornadoes occur east of I-25, they do happen in the mountains, but there's only about 10% of the time that we get them up to the high country. Now, this is a supercell tornado. Big, ugly looking spaceship kind of cloud, because the whole cloud is rotating. And on the Doppler, we can see where the red and the green is. That's the Doppler looking at the wind directions, looking for what we call shear. Very close together, winds are doing this. That's what the radar can see. And so that's obviously a rotation. And this is a hook echo over here. That's actually on the Windsor tornado right there. And of course, that's the big kind of tornado that you see out of a supercell. And this, of course, was Windsor, May 22nd, 2008. A very unusual storm because it developed at 11:30 in the morning. In Colorado, most of our tornadoes occur in the late afternoon into the early evening. It moved from the southeast toward the northwest, kind of opposite of what you normally see, and it was a powerful tornado that occurred very close to the mountains. We usually see the bigger ones farther out on the eastern plains. Had this storm developed farther south, it would have done a damage path from HEB all the way through downtown Denver. So we came really close on that one being a huge story. Now, rating tornadoes, which is the Fujita scale, which is named after Dr. Ted Fujita from the University of Chicago. He had, back in the 70s, been comparing damage from what they had seen at Hiroshima to damage they see from tornadoes. He thought we can maybe establish a scale of how powerful these storms are. It has been upgraded to what they call an enhanced version because now they kind of look at the type of structure, brick versus frame, that type of thing. So weak tornadoes, and this would be most of our gustnados, our landspouts, tend to be what we rate an EF0, winds of 65 to 85 miles an hour. They'll cause some damage, knock some stuff off your roof, mess up your trees. So the EF0 and 1 are the ones we'd be most likely to see around here. And the Southlands tornado was probably an EF1 or maybe a 2. That's getting on to moderate speeds about 111 to 135 miles an hour. Those start to cause some pretty good damage. And then the EF3 gets you up to winds of 136 to 165. You get a lot of trees damaged, roofs off, windows blown out, power lines down. Now, then you get to the big ones. EF4, sometimes we don't get anything bigger than this in a year, but that is up to 200 mile an hour winds, and you can see the kind of damage. And then the finger of God from the movie Twister is the EF5, and these are just incredibly violent storms. That would be some of the ones that have hit Oklahoma City. We talk about an EF5, that's a storm you might not even see every couple of years. Now, Colorado is right on the edge of Tornado Alley. Now again, 90% of our tornadoes occur east of I-25, and we get close to 50 twisters a year. Texas, of course, big state, a lot of room for them to run around, so they get about 140. Kansas, Nebraska, Oklahoma, they're all up there too. Farther west, you don't get very many. Farther east, you don't get many. The reason for that is the mountains, the Rockies and the Appalachians. What that does, if you think about the topography, we have a long, flat plain from northern Canada all the way to the Gulf of Mexico. It's very easy for warm, moist air masses from the south to flow north. Very easy for cold, dry air masses from the north to come south. They collide, we get most of our tornadoes right here. They mostly in the west are dominated by just a Pacific air mass, and the Appalachians are more dominated by an Atlantic air mass. So we get the big contrast in temperature and air masses. Watch versus warning. So a watch we will issue when conditions look right for severe thunderstorms and possibly tornadoes to develop over a period of hours, maybe 5 to 6 hours. And that's issued by the Storm Prediction Center, and they're located down in Oklahoma City. And so it's a large area, like most of eastern Colorado. When a warning is issued, that means we either see a tornado from a spotter, or radar indicates, I showed you that little coupling on the Doppler, that there's rotation in a storm. So it's really, when I come on with a tornado warning, listen carefully if I say, spotters have seen a tornado on the ground, or if we're saying radar indicates, because if it's a radar indicated, we don't have anybody out there to see it. But what we're doing is saying, because the storm is rotating, we're kind of watching what it's doing, it could very likely produce a tornado.
But your camera system has gotten something.
We do have a big network of cameras now. I talk about our Viero wireless camera network. They're the cell provider out of the Eastern Plains. And they have cameras on all their cell towers out there so they can monitor if the towers are okay. And so they called us about a year ago and said, would you like to partner with us and you can display our cameras. So we have about 50 cameras all across the Eastern Plains into Kansas, Nebraska. And it's an exclusive, folks. No other station has that. Now, it is really helpful though, because we can actually pan the camera out and see what's going on. Storm Shield, I talk about a lot on TV. Now this is really a great app. And if you go just to Storm Shield app on your phone, it works for Android or for Apple devices. What this does is it immediately sends you the warning. from the National Weather Service. Now, weather radios have been around for a long time. I think they're great. But the problem with the weather radio is it issues the warning for the entire county, which means if there's a tornado anywhere in Arapahoe County, your radio goes off. That could be out in Deer Trail, that could be way out in the Eastern Plains, but you get alerted. Well, sometimes that's bad because people kind of get a false sense. It's like, my radio's going off and the sun's out. You know, this thing doesn't work very well. I don't want to have that radio keep blasting like that. Storm Shield does what we call a storm-based warning, a little tiny box that is only for where that warning is, and it really works fast. Now, this is brand new. We now can do it for more traditional phones as well. If you've got an older cell phone, a flip phone, or a landline, you just want to call the house on the landline, if you go, we have Storm Shield phone call alerts. Click one more, I think we have here, dear.
I'm sorry.
That's okay. Nope. Storm Shield phone call alerts to be able to get that as well. If you can't find it, drop me an email. Okay, on with the show. Do you know that this is the original Cray 1 supercomputer? It's in the basement at NCAR. It's from the 1970s. What you guys have right now in your hands or in your pockets, 25 times more power, computer power, than the original Cray 1. They use it as a piece of furniture up there right now. It's pretty cool looking. So we have a lot of stuff. You basically today can have a weather center on your phone. You can get storm information, you can have hour-by-hour temperatures, school closings, radar. It's pretty cool, the technology we now have. And there's a lot of sources, you know, I'm on Instagram, I'm on Twitter and Facebook and all these different things. That does make it a challenge for us now in the television business to say, how do we stay relevant? Why do people want to sit through the commercials when they get all this stuff already?
Because you're funny.
Well, we hope to be fun. Yeah. So here are different National Weather Services that serve us here. We're mostly just going to hear from Boulder, but Goodland takes the far eastern counties, Pueblo's down to the south, and Grand Junction is a huge chunk of western Colorado. Of course, lightning, you know it's dangerous. Even if you're having a great round of golf, it's very dangerous. So many fatalities coming from that. And we're out in a high lightning area. Last summer, we're playing golf. We're coming up on 18. And I'm watching Cindy. The clouds are getting dark. Heard some thunder off in the distance, but it's still pretty far away. We think we're pretty good. And Cindy has a putt, and it's curling right, about a 10-footer, and it's curling right toward the hole. And she goes like this with her putter up in the air, and I kid you not, I'm over here, so I'm seeing her. Behind her, I think it must have hit on 10. Bam! This lightning bolt comes down. And it's one of those that the thunder was immediate. We all hit the ground, and we're playing with Norm Bledsoe. And he goes, everybody two-putt. We just... So please, if you can hear the thunder, it's getting really close. And if you could really see that lightning close by, you know the rule, 5 seconds, right, for every mile.
So when the weatherman's wife gets killed...
Oh, God, that would be so embarrassing. Okay. Yeah, go ahead, Cindy. Bob. And of course, straight line winds. Now these are different than tornadoes. That is what we call a downburst straight line wind. The moisture comes straight down and then blasts out in all different directions. This will still get 100-mile-per-hour winds and can certainly be very dangerous things. And these are the kind of things that they look for very carefully out of DIA, because if you have these outflows, these downbursts, they will put a hold on takeoff and landing. And the key thing there, go back one quick time, so, is that when that air comes down and fans out, of course, airplanes want to land into the winds. They have more airflow coming over the wing surfaces. If all of a sudden there's a thunderstorm behind that aircraft that blows out this gust, and you're coming in like this, low and slow, and suddenly instead of a 20-knot headwind, you have a 50-knot tailwind, what's your airplane going to do? It's going to fall quickly. So that's what's very dangerous around airports. Okay. And of course, flash flooding, 6 inches of water. You saw some of the stuff from Houston this week. People, what are they doing driving through this stuff? When a car is suddenly floating, it does not float like this. It floats like that because the engine is the heaviest, and then it falls upside down. And people don't realize that. Right. Unless you have a beetle, right? So please be very careful with flash flooding. All right, so Colorado weather is usually the best in September. When people call me, I want to have an outdoor wedding. When should I do it? September. When a bride calls me, it's June 15th and I have an outdoor wedding at 4 o'clock.
What do you
Who
think?
are you? What were you thinking? So September is usually, as we know, the best month of the year, except
When our daughter got married.
that's a whole other story. Yeah, just 2.5 years ago, the big flood in 2013. Let me talk a little bit about the meteorology with that flood. Bob. So here's what happened. This was kind of unusual. We get the monsoon flow every summer. It usually kicks in late July and through August. That's that moisture that comes up from the south, and we get the daily dose of heavy rain producing thunderstorms. Well, in this case, it was a late monsoon, and we had a front that was stalled across the central part of the state. And then higher up in the atmosphere, we had all this moisture coming up, and it just bang, collided right over us, and it stayed there for several days. Go ahead, Bob. And so we got a year's worth of rain in 5 days in some areas, talking 18 inches, even up to 20 inches of rain in parts of Boulder County. And we had this secondary little blast that came all the way down here into Aurora and all the way down into northern Douglas County. And of course, water flows what? Downhill and toward money, right? That's what they say. So we had this tremendous flooding up on the South Platte. So the question is,
I'm going.
people have asked me, was that flood global warming? Was that caused because the climate's warming up? Now I'm going to talk a little bit about global warming. I'm not going to do any politics on you. This is strictly science. Obviously the temperatures are warming up, heat waves are going to become more common. And floods, more energy in the system, so you might make that flood just that much worse. But for individual weather, like tornadoes or individual storms, it's a lot harder to attribute because frankly, that's weather. Weather happens. You get those things to occur. So some parts are easier to attribute than others. Bingo, Bob. There we go. Now, I'm not a climate scientist. I'm a meteorologist, so my expertise is a much shorter time frame. But my feeling on this is that most people in the United States are not going to meet these experts at NCAR. You're not going to see them on the street and say, hey, Kevin Trentworth, tell me about global warming. They see television weathercasters every night, and you are kind enough to invite us into your homes. And so I think with that, there is a responsibility for me to be as well versed about this as possible. You get this a lot from last week, you know, hey, 3 feet of snow, where's your global warming? Well, it's snow, it's winter, that's weather. Go ahead, Sid. And weathercasters, trust me, all the time are asked on TV to explain these things because we're sort of the station expert on natural phenomena. So they'll say, hey, Mike, there's a comet. Can you do something about that? Or, hey, Mike, there's a big volcano down there, Popocatépetl down in Mexico. Can you do a little thing about volcanoes or tidal waves or whatever? They ask us to do that stuff all the time. So why wouldn't meteorologists be as well versed as possible about a topic as big and important as climate change? Now, there are a lot of things that are out there that we know, okay? We know that the Earth's climate from ice age to ice age is controlled by the heat of the sun, the shape of the orbit of the Earth around the sun, because that does change over cycles of 50,000 to 100,000 years, and the chemistry of the atmosphere. So when people say, well, it's the sun that's the biggest thing out there. Yes, the sun, obviously we wouldn't be here at all without the sun, but the cycles that we're seeing in terms of temperature are not adding up. So the sun is not changing, it's not getting hotter. It's actually cooled slightly, and temperatures ought to be dropping back just a little bit. Okay, Bob? Downfall. And then a lot of times I'll hear this, yeah, hey, it hasn't warmed up since 1988. This is out there all the time. And that's because we had a huge El Nino that year that put a lot of the heat that was stored in the ocean out into the atmosphere. And after that, we have not had as strong an El Nino until this year. And so what you need to do is take a longer trend. You go back with the temperature records back about 130, 150 years. And even there, though it's an upward trend, you can see it does it not like a steady ramp, but it does it in kind of a staircase. And the reason for that is that the ocean sucks up most of the heat that we're getting with the increase in carbon dioxide. And so it's stored in the ocean. Think of the heat capacity of water. You know, lakes don't freeze over on the first cold day. They stay open for a long time into the winter. A lot of times people will say, Mike, carbon dioxide is just a trace gas. How can this small amount of, we're talking parts per million, have such an effect? Well, A good analogy, and this was an NCAR researcher gave me this one. Think of each molecule of carbon dioxide like a feather in a down comforter. On a cold night, if you're in bed with just a lightweight blanket over you, you're cold. But if you have a nice, heavy, thick down comforter, it traps the heat of your body and you stay warmer. So what we're doing is we're adding more feathers to this comforter that is our atmosphere. And people might say, well, that's just a trace gas, but if we had the same amount of carbon monoxide in the room right now, we'd all be passed out and close to death. Now, carbon monoxide is poisonous, carbon dioxide is not, but the analogy there is that small amounts of things can make a big difference. I weigh 200 pounds, maybe a little more, since I moved out here. It doesn't take 200 pounds of arsenic to kill me. You know, trace amounts can make a difference. Now, this is Cindy, look at that, that's prom. Isn't that great? Oh, man, I wish I still had that suit. So, I hear this one a lot too. People say, hey Mike, but back in the 70s, you guys were all saying we're heading for a new ice age. I mean, the Time Magazine and Newsweek had all this stuff. What's going on there? Well, actually, I was, go ahead to the next one, a student at the University of Wisconsin in the 1970s. That's the meteorology department right there. Dr. Reed Bryson, who was one of the founders of the department, was still on the faculty there, and he would do talks about his dirty window theory. And what they was since World War II, all the aerosols, the particles of dust that we put into the atmosphere were creating a dirty window. We weren't getting as much energy from the sun. Now, in the mid-1970s, we had a series of very cold winters, especially in the upper Midwest, and record cold. And so some of the newspapers and the Time Magazine stuff latched onto this and ran headlines about the new ice age that was coming because of this dirty window effect. But actually, if you go back, even then, look at how many more papers, as indicated in the red, were being written about warming compared to cooling. So even though that made headlines because we had had some cold winters, the vast amount of research was saying, but the carbon dioxide is going to continue to warm things up. So there's some analogies. People come up and say, hey, it's snowing in, fill in the blank, Las Vegas, Jerusalem, whatever. I mean, we can't have global warming. Senator Inhofe throws a snowball in the Senate, and it's good. We don't have any global warming. But remember, that's weather. Okay, weird things happen. It does snow occasionally in Jerusalem and in Las Vegas. So the analogy that I like to use is that weather is one play in a football game. Climate is the history of the NFL. Okay, so if it snows in Las Vegas, it's wintertime. We expect more unusual local weather events as the climate system gets more energy. Global warming is creating a steroid effect in the atmosphere. That's why I put Sosa and McGuire down there. And most of what we see is natural variation. So when someone says that tornado is because of global warming, I don't buy that. But the steroid effect is adding about 5 to 10% more juice into these weather events than what we see with natural variability. Now, another thing I'll hear from people is the thermometers. I mean, I see these websites where they show a thermometer out on a hot asphalt roof. Well, no wonder those readings are inaccurate. Well, yeah, that reading is inaccurate, but we know that the ice doesn't care. And if you look at the size of the ice sheet over the pole, it is shrinking. You know, periodically these do expand and shrink, but we're seeing a tremendous amount of shrinking. And anecdotally, going back to whalers and native populations going back to the 1800s, this is unprecedented. The permafrost melting in the Arctic regions where villages are just sinking into the ground. And the coral, I don't know if you've been following this, the Great Barrier Reef is having an unbelievably bad die-off right now because reef systems are very fragile to temperature. And if it gets too warm in the water, the reef expels all of the living matter and you get a dead reef. And these do not come back quickly. Okay, so they tell the story there. Now, I get this one all the time. Hey Mike, you can't even predict tomorrow's weather. How can you predict a century from now? Well, predicting weather is very different than climate. Weather is much more chaotic. You know, we go from a blizzard last week to 70 degrees, a little like that, but that's what weather does. Climate is like this. If you were planning to go somewhere warm in January, and you had to make the reservation 6 months ahead of time, would you make a reservation to go to Miami, or would you just stay here in Denver? You'd probably make a reservation to go to Miami, because the climate of Miami is that it's warmer in the wintertime than Denver. But doggone it, the timing was just bad. We get one of these big fronts that comes in, and Denver's 70 with a Chinook wind, and it's 55 degrees and raining in Miami. Should have stayed home. That's weather versus climate. So climate is actually easier in some ways to model over a course of decades. They'll say the computer models are not really good enough. They're getting so much better all the time. Mention that your phone is 25 times more powerful than the original Cray computer. Think how the new computer system that they have up in NCAR, which is actually located, the computer's up near Cheyenne, Wyoming, has 10,000 cell phone power. So think how much more power that is than what we're talking about with the original Cray. And then sometimes I just get that the climate scientists just trying to achieve worldwide domination like Dr. Evil. Okay, Bob. All right, and so given that, this is the typical hangout where the super wealthy climate change scientists can be found. So this is the harbor in St. Bart's, okay? And sitting guys, because our friend the Kellys, the guy that invented the weather computer, made a lot of money, sometimes they'll invite us to go to St. Bart's with them. But I have never seen the climate scientists down there yet in all of the times I've been to St. Bart's. Matter of fact, I went up to NCAR just this week, because I was speaking at Boulder, and I thought, I'm gonna go to the parking lot at NCAR and see what kind of vehicles we have there. Look at this beauty right here. And so I just, if these climate scientists are making a lot of money off a scam on climate change, they are not investing well, because they're driving 10-year-old Corollas up there. So anyway, what do we really know? Here's what we know for sure. The greenhouse effect is good. It's real. If we did not have the greenhouse effect, we would not be here, folks, because the temperature of the Earth would be about 60 degrees colder. It would be just a frozen ice planet. Okay, so we know that for sure. And this is not new science. Actually, in 1825, Joseph Fourier, who was a French mathematician, figured out that the distance from the sun to the Earth was far too great for the Earth to be as warm as it was. It should be much colder with the amount of energy we'd be getting from the sun. And so he realized that it was the atmosphere surrounding the planet that kept us warmer. In 1865, end of the Civil War, John Tyndall, CO2 is the gas. They could measure this in the lab, looking through tubes of gas, that absorbs the long wave, or the Earth energy, the energy being re-radiated back from the surface of the Earth. And in 1895, Svante Arrhenius, who is a Swedish chemist, figured out that a doubling of CO2 would warm the Earth by several degrees. So this is not something that's at all new. And we also know, because we can measure it up at the top of Mauna Loa in Hawaii, that we are continuing to see it growing, and now we're up to about 403 parts per million of carbon dioxide. So that's what we know, okay? And we know that if it's warmer over the course of, not given weather, but over the course of decades with climate, we're going to start to see earlier snow melt, which means we're going to have longer, hotter conditions, drier conditions, water issues. We know the population is going to continue to grow, but we probably see less water overall. So that's a concern that we're going to have.
I'm confused.
Bob?
There's less snow in 2002 than 2008.
Different years.
So what are you trying to say here? I'm lost.
Okay, April 2002, snow melted out quickly. We had less snow that year. 2008 was a bigger year. So this year we're doing pretty well, but some years, remember 2002? That was the Hayman fire?
Yeah.
Yeah. So that's the issue. We're going to probably have less years where we have good snowpack. There are more years where we have less snowpack, and it's all going to melt out early.
Okay.
Thanks, Bob.
Sure. I got it all.
But if it gets warmer, it does not mean we're going to not have snow and cold. Weather varies greatly. Blizzard of December 1913 in Denver. Go back. And blizzard of 2003 in March. Still have the cable cars. I think that's great. Okay. And this, I love how we've changed in the media. December 1913. You probably can't read the headline there, but this is what they wrote. Denver, milady of the snows, jauntily doffs her gray mantle and smiles. How poetic is that, right? And then, now we get snow, wind, wallop, state. So, one of my favorite quotes is attributed to Einstein. It's the significant problems we face cannot be solved at the same level of thinking with which we created them. And so, I don't look at the global warming issue as like this dire doomsday kind of thing, because I'm looking at a lot of things we can do. You know, we take our cell phones for granted. They didn't exist 15 years ago. Think of the changes in computer power that we've talked about. We don't, look at all the miraculous things happen in our lifetimes. We don't know what stuff is going to happen in the next 50 to 100 years. So we can do a lot of this stuff. We have the ability. But the line there is, what if it's all a big hoax and we create a better world for nothing? Go on. So we do a few different things. At Denver 7, we have put solar panels up on the roof. We put solar panels at our radar site. We haven't done it yet here, but we had solar panels at our house over in Saddle Rock. And I have that little red Chevy Volt that gets 115 miles per gallon.
Which is why he won't buy me a
Golf cart.
golf
So I already have an electric car. Sorry, dear. Go ahead. So, when Yuri Gagarin, the first human in space, got to the edge of the atmosphere, he got up to orbit height, he looked out of his tiny porthole in his Soviet spacecraft, and he was terrified. He wasn't terrified that there was something wrong with his ship. He was terrified because he had been taught since he was a little boy that he lived at the bottom of a great ocean of air. And when he got up to the edge of the atmosphere and looked out at this little thin membrane that separated us from the cold blackness of space, it terrified him. And as far as we know, out of the vastness of the universe, Earth is the only place that harbors life. I think we'll find other places, but they're far, far away. So I'll finish up with this last little slide here. There's the fan. There it goes. To me, it just seems prudent, patriotic, and reverent that we do everything we can to protect and conserve this fragile envelope of air that allows us to live here. Is not a dance that brings tornadoes. It merely explains them. Not like a rain dance. And it is a group participation dance. So at any point during the demonstration you want to come and join me, you're certainly welcome. What we're going to do is we're going to split the room in half. Okay, this is the south side of the room, and this is the north side of the room. Now, in order to do the dance, we got to pretend a couple of things. I'll put this down there. First thing we need to pretend is that it's really, really hot outside. Southsiders, give me that. Just a hot, sweaty, steamy summer. Oh, I felt the emotion. That was great. All right. Now, next thing, let's pretend Denver's down here at my feet in miniature. A little tiny Denver. A little bitty Rocky Mountains, a little bitty downtown Denver, and over here a little bitty HEB. Now, when it's really hot, here's what's going on in the weather. Here's what's happening meteorologically speaking. What we have is a great big bubble of hot air that's parked itself on top of Denver. A great big hot air mass. If you want to be more scientific about it, a great big blob of hot air. What I will do is I will play the role of the great big blob of hot air. No comments. Some people say this is an easy part for me, by the way. So I'm kind of floating over Denver like this, great big blob of hot air, and everybody down below is hot and sweaty. Let's go, Southsiders, that's a cue. Hot and sweaty and uncomfortable and miserable, and I, as a great big blob of hot air, I am very, very happy about it. Because this is what blobs of hot air do for a living. You know, they make people hot and sweaty. I'm just doing my job up here. So I said to myself, man, this is great. I love floating over Denver, making everybody sweaty and miserable. You know, I don't think I'm ever going to leave. I'm just going to stay right here. Stay here for years. Great big blob of hot air. Okay, well now, let's pretend that we are up in Canada. Now, if we are in Canada, and if we are air, we're going to be a lot different than the air down over Denver. We're farther north, farther away from the equator, closer to the North Pole, less heat from the sun. So if you're Canadian air, Northsiders, what are you going to be like? You're going to be chilled, you'll be cold, right? Or as I like to say, if you are Canadian air, that means that you are cool. So the cool air's kind of hanging out in Canada, checking out that Canadian scene, and the cool air finally says, you know, I am way too cool to be stuck up here in Canada. Eh? I think I'm going to cruise on down to Denver and cool everybody off. So the cool air leaves Canada, starts heading down toward Colorado. Cool air's getting close to the hot air, and the cool air goes, hey, hot air, why don't you clear on out of there? Because I'm coming in to cool everybody off. All right, well, while the cool air is moving in, what's the hot air doing? Is it moving out? No, it's hanging out. It likes it here. It's like everybody else that moves here, doesn't want to leave. And so the hot air's kind of like this, and it looks over at the cool air and goes, no way, man, get lost, go back to Canada. You're not getting me to leave. I'm staying right here. My friends, we have a problem. Hot air doesn't want to leave. Cool air knows that it would be uncool to chicken out and go back again. So the cool air says, now wait a minute, hot air, you've been there long enough. Time you clear on out. Matter of fact, if you're not going to leave, I'm going to make you leave. And the cool air starts pushing on the hot air to get it out of the way. Hot air's kind of big though, so it's like, whoa, come on, hot air. Hot air is getting pushed around like this. Hot air doesn't like that too well. Finally gets fed up with it and goes boom and throws an elbow at the cool air. Cool air catches his elbow, knocks him backwards like this. Cool air won't take that line down. Cool air comes back, gives a bigger shove to the hot air. Hot air comes back, a great big shove against the cool air, and pretty soon these two air masses are really going at it. He didn't know this was happening out there. My brother is so excited. This big fight between the two air masses occurs along the cold fronts that I show you on TV. Those little blue lines with the blue points. As the two air masses are duking it out, what happens is the cool air is slightly heavier than the warm air. It begins to wedge under the warm air mass, forcing the warm air to rise. That rising air is what builds up into great big thunderstorms. The air inside a developing thunderstorm, we call it the updraft, goes up through that storm like smoke through a chimney, which is why thunderstorms get to be so tall. Now, everything I've told you will give you a big thunderstorm with thunder, lightning, hail, rain, but it won't give you a tornado. There's one more thing we need, and that is something I show you on TV all the time called the jet stream, the little river of fast-moving air that determines our storm track. If the jet stream happens to be blowing at about 25,000 feet, strong over Colorado, here's what happens. The air rises through the thunderstorm until it gets up to the jet stream. The jet stream racing by causes that thunderstorm cloud to start to turn and to start to spin. And what we find is the entire thunderstorm will begin to spin very slowly. Now, you've seen a figure skater on ice skates do one of their spins. They start with their arms out like this, and they're spinning kind of slow. But as that skater begins to pull their arms in, they start to spin faster and faster and faster. Get ready to catch me in the front row if I lose this. It's getting harder. The same thing happens in the thunderstorm. The air rises through the thunderstorm like smoke through a chimney until it gets to the jet stream. Jet stream racing by causes that thunderstorm cloud to start to turn, to start to spin. The spinning starts out big and slow, but then, just like the figure skater, gets smaller and faster and faster and smaller, and the tornado will drop down to the ground. Okay, those are the basic steps. Let me put the whole thing together and do it for you really fast. If you want to join me, come on up. Nobody ever has. We start with the hot air floating over us. Go south side. Everybody's hot and sweaty. Oh, yeah, beautiful. Hey, you north siders, there up in Canada. Cold. Yeah, cool air starts moving on down like this. Cool air comes in. Hey, hot air, why don't you clear on out? Hot air's over here going, no way, man. Get lost. Cool air won't take no for an answer. Starts pushing on the hot air. Hot air's like that too well, so boom, throws the elbow. Cool air gets knocked backwards like this. Cool air won't take that line down. Comes back with a bigger shove. Hot air, big shove back. Pretty soon the two air masses really going at it. Big fight going on. Big thunderstorms build up above this battle between the two air masses. The air in a thunderstorm goes up like smoke through a chimney. But if the jet stream's around, zoom, the jet stream going by starts to make the whole thing spin. And it's just like a figure skater, smaller, faster, faster, smaller. And the tornado forms way up the middle of the storm and grows on down through the storm all the way down to the ground. And that is the tornado.